If your database is only as good as it performs, how can you ensure it meets every standard? Kevin Klein of SolarWinds is here on Future Proof to tell you all about the best management hacks tailored for the databases of today. Think like a developer while operating at the speed modern consumers expect. The sweet spot is near, and we'll show you how to reach it right here on Future Proof.
The future is here already. It's just not evenly distributed. Yet. Today's world teems with innovation. The nexus of hardware, software, and human ingenuity promises a revolution in possibilities. What does tomorrow look like? Witness Future Proof.
Yours truly, Eric Cavanaugh, here with our good friend, the evangelist, the tech evangelist. This guy knows almost everything, at least about data and systems and troubleshooting and all that kind of fun stuff. Kevin Klein, tech evangelist for SolarWinds, is with us, and we're going to talk about the foundation of the information economy, and that is still the database. Yes, there's data fabric, there's data mesh, there are all these different ways that you can store and persist data. The database is still the foundation, and it's going to be the foundation for quite some time. And I was mentioning to Kevin before the show, with database performance, well, it's the kind of thing where if it's not performing, you're not happy. And other people aren't happy. The system is slow. It just disrupts the workflow. It causes morale problems. It causes all kinds of issues, and people get very unhappy. And understanding all that is pretty darn complex and has been for a long time, like really getting into the weeds of knowing why is this database having trouble has been difficult. But we've seen this trend the last few years of observability. I think a lot of it was kickstarted or at least jump-started by the Kubernetes movement, because Kubernetes came in thanks to Google, and you had containerization. We had Docker before that, but Kubernetes really won that war. And because of Kubernetes, we have this explosion of observability vendors. So it's fun. We're getting to the place where we can see. And now the question is, what can you do about it? How do you understand what's happening? And what does all that mean? And that's what Kevin Klein is going to tell us about. So Kevin, welcome back to the show. Tell us about what's happening from SolarWinds on the database performance side.
Well, great to be back on the show, Eric. Thank you for having me.
Yeah.
With SolarWinds, we have a large number of customers, hundreds of thousands of customers, many in the Fortune 1000, very large entities, but we also have a very large number of small and medium-sized businesses. Businesses that frequently do not have a database administrator on staff. And so one of the things that we're seeing is that, as you mentioned, the complexity of our systems are so great now that even if you're well informed about what, let's say, your in-house application does, you're one of the developers on the team or sysadmins who helped deploy it, it talks to a database, you kind of think of the database as a black box. I send it select statements and inserts and updates to operationalize the data that this particular application does for us. Maybe I write some reports, and then I keep my fingers crossed. And so one of the things that we see in those small and medium-sized businesses is that there's a real shortage of expertise. So it's not uncommon for a team to have very experienced developers who have been working with their chosen software language for years, decades, and they're great at it. But once it comes to that database, they know how to write SQL, but maybe not very well. And so, like you said, getting to the point where you have a slowdown can be really surprising and uncomfortable for these organizations, because how do I troubleshoot it? How do I even make sure my team is aware that things are going sideways in advance, rather than learning from my phone blowing up and my end users calling very angry that something is wrong? And so I'll be honest with you, I blame academia, which is yeah, it's kind of funny. My brother's a professor, so it's a half joke because I like to stick my elbow in his ribs. But I when I went to college in the 80s, I got a bachelor's degree of management information systems, and there are similar names today. And the other main computer-oriented degree at that time was in the School of Math and Engineering, and it was computer science. And so if you graduated with it, even today, a degree in computer science, we pretty well know that you're going to have certain understandings. You're going to have a certain baseline of knowledge. But there is no bachelor's degree of data management. And so what we find is maybe we're lucky in the interview process that we have hired someone or are considering hiring someone with a certification, because now we do have a baseline understanding of what they know. But that is, that's not common. Even the certifications aren't that common. And so we find ourselves in a situation in which you might have someone who gives you a resume and it says they have 5 years of database experience. You think, oh, that's pretty good. That's the best we've seen so far. But in fact, they actually have 1 year 5 times over, right? So they know how to back up a database and they know how to troubleshoot a simple select statement or something, but they're really not solid database professionals. Mm-hmm. And that's something that is really, really tough, because as you said, if the system slows down, we can measure the impact of that in dollars. Either, wow. We're not getting enough sales transactions through. People are leaving the website because they can't put things in their shopping cart in a timely way. So we even say slow is the new down. And
I like that. I've heard that. I like that. It's true. It is the new down. Yep.
And so our tools build in a lot of that kind of global high-level expertise of database professionals and make it much easier for you, not only to see metrics that you may not even know exist, but it puts them in light of what meaning do they convey, and what's the resolution when you see a particular sort of problem.
Mm-hmm. And there are lots and lots of things that can go wrong, especially with a large database or a multi-node database. For example, we have all these distributed databases these days. There are issues with the RAM, there are issues with spinning disk, there are issues with the network, you have network latency. And this is why it gets complex, because you have 5, 7, maybe 12 different factors that are coalescing to create some shortage. And even just a handful of years ago, I mean, you had to have an expert to be able to look and say, CPU usage is going up, but memory is low, and the network is at this place. Oh, I know, it's probably this node failed or something. Point being, you had to know a lot to even know which questions to ask and where to go. And that's starting to change now, I think, because of this observability, because of automation. I mean, even things like configuration settings, one weird little setting in there somewhere can cause you a lot of trouble, right? So how does this technology address some of those issues? Are you able to automate some of that stuff, or maybe just get into the weeds a bit?
Yeah, we do look into all of those sorts of things. And as you pointed out, it's just so much more complicated than you might think at first glance. And that's even made worse because the paradigms, the mental models that we use as developers are often at odds with what database designers use. So databases are designed around sets of data. You write a select statement that has a from clause and a where clause, so I want everything from this table where it has these characteristics. But developers tend to write their code to address one line of data at a time. And when you do that, that makes your database super slow. So we have in our different products, we have tuning advisors depending on the area where the difficulty might be found. So for example, in Database Performance Analyzer, we have index tuning advisors. So it could say, based on this workload, say from 8 a.m. on Monday to 5 p.m., the normal workday, these indexes aren't used at all, and these other indexes are really not best for the workload that you have. Mm-hmm. We have table advisors, and this is important because many times not DBAs so much as developers will choose a poor data type for the kind of data that they need to store. So a couple of very common examples there is to use a GUID as your primary key. Now, GUID sounds great because it's a global unique identifier, and your primary key is your unique identifier for the records in a table. But the problem is GUIDs are typically 16 bytes in size, so you can get a unique identifier with a big integer data type in a much smaller space. That's the first problem. But the second problem with GUIDs is that they, because they're so unique, they just scramble all your data across, I guess you could say, logical fragmentation. And so it's particularly bad on spinning disks, and it can be much, much slower, particularly for things like insert and update operations on SSDs. And then finally, we have the query tuning advisors. So it says, based on this workload, and you have these different select statements and so forth, then if you add an index onto or change the columns in an index, all of these queries will see at least a 10% improvement in performance. These other queries will benefit from having an entirely new index added on. So we give you a lot of really prescriptive, detailed information about how you can make your workload better.
Well, that's very interesting, because to create the indices strategically can make a huge difference. And that requires to know what questions people are going to be asking. So what you want to be able to do is monitor what questions are being asked, and then dynamically provision, or at least suggest. That sounds like that's what you're doing, right? You're watching what's coming across the transom, and then having the system say, we see you're doing this. We recommend creating an index on this particular dimension. Is that about right?
Exactly. So, for example, your primary key in one table, you'll want that indexed, but it's going to probably be a foreign key in another table. For example, you've got your sales order detail table, and people will order different products. So the product table will have its primary key, but your sales order detail will have a foreign key to make sure that nobody puts in products that don't exist.
Right.
But it's a very common thing for developers to say, I need a foreign key, but they don't remember they have to also separately add an index to that.
Interesting.
Right. So this will come back and tell them those sorts of things.
Right. And so it's interesting, because what you're referencing is an information architecture and things like data modeling. And data modeling, I always used to try to wrap my head around it. And really, it's all about optimizing the performance of the system for the particular use case. That's why you spend time modeling data, is because you want to ask yourself, okay, how are we going to be using this information? We want to enable the customer to search for products very easily. So that's creating indexes. But then we want them to be able to go and buy stuff. And I often explain to people why, when you're in Amazon searching for stuff and then you go to buy something, it switches over to this whole other system, because that system is transactional in nature, is designed to capture the money and actually order the product and send it on its way. It's a different system from the searching system where you're looking for stuff, because these environments have been optimized for the functionality involved. And that's why you switch from this system to that system, right?
Absolutely. And in fact, that's part of the whole discussion around, should I use a NoSQL database or should I use a SQL relational database?
Right.
All the relational databases, their genesis was back in the 70s when we didn't even call it information technology back then. We just called it data processing. And we just did what scientists and accountants did, only faster, right? Wow. But those were all systems typically, like a banking system. And that was all run on batch mode processing on mainframes. And if your mainframe happened to lose track of a few records of your data, which they would often do in the 70s and early 80s, but people were not okay with that. They'd grab their pitchforks and their torches and march on the castle and burn it down. So that's why they invented those relational databases. The whole premise of a relational database is built around what's called the ACID property of transactions. It must be atomic, consistent, isolated, and durable, most of all durable. So that if that mainframe crashes, I can recover the transaction either all the way to completion, or I can roll it all the way back so that you don't lose any money.
Right. Talking all about database performance and observability and understanding what's happening. And Kevin, you made a really good point in the last segment about the different kinds of functionality. And you might appreciate this. Back in 2005, I interviewed a guy I'm sure you know named Dr. Michael Stonebreaker, who
Yes.
invented the modern database in many ways. And I remember he was on this whole push of one size fits all. And his point was that one size does not fit all. And what he was saying is that up until that point, relational databases had just ruled the day, and everyone used a relational database for everything. And his point was, it's good for some things. It's good for ACID transactions, like you talked about. It's good for data warehousing, and it employs set theory, basically. But he said for some particular purposes, it's not optimal, like analytics. And he talked about a column-oriented database, and why that's important is because in the columns, you're supposed to have the same kind of information, so you can compress it very easily, to move it around and to do analysis on it and things of this nature. And there are lots of other kinds of databases. There are object databases. There are graph databases that have really come to prominence in recent years, in part thanks to Facebook and LinkedIn and Kevin Bacon's 6 degrees of separation, all that kind of stuff. For those kinds of queries, graphs are very, very powerful. They're kind of slow, but the point is you want the right database for the right purpose. And now we have like 420 databases are listed at dbengine.com. That's a lot.
Right.
That's a lot. And so it really pays. And I mentioned this in the last segment. Before you actually launch your application, your production system in your organization, you really want to spend time thinking about what do we want this thing to do and which database should we use, because to your point, the performance will be 100x on this versus that depending upon the use case. So how do you help clients, and how does this new technology help clients make better decisions about that?
Well, one of the things that we know, if we talk to social scientists and to neurologists and so forth, is that people aren't really good at remembering discrete facts and details. That's why they encourage us so often, and something that you're a master of, is to tell stories, because people remember stories much better than a list of tabular numbers. And so in the same sort of way, the human brain is extremely good at finding patterns to match to. And the flip side is we're also good at seeing when things don't match the pattern that we expect. And so we basically codified that into Database Performance Analyzer, in which we have anomaly detection. The longer you're able to watch a database system, the longer it's able to build a kind of a corpus of knowledge of what's normal for this database. So it might be normal for a CPU to spike every night at 1 a.m. for 30 or 45 minutes because some important kind of off hours task runs. So it won't give an alarm to anything like that. But then suddenly, on some random Wednesday night at that time, we have 300 user connections when we don't normally. Well, that's an anomaly.
Right.
Even if we didn't blow up the CPU or consume all the memory, there's still something very different about this workload. And so the tool is able to point out anomalies to you, which is so much easier when we're dealing, especially with people who don't know a lot about technology. And of course, I'm speaking about our business users. So if you work in corporate IT and you're on an application team or a DBA team, and someone on the business side says, why is our application running so much slower? If you were to talk about context switches and page latches and their eyes will glaze over instantly. But if you're able to say, well, I guess we opened up a new office because it seems like we're getting 20% more activity out of the southeast of the United States than we got at any time in the past. Well, they instantly understand, oh, yeah, we did roll this out to our stores in the Southeast. So it becomes part of the story, the narratives that we know about our application. Instead of details and figures, we can quickly look at the tool, we see a pattern match or mismatch, and it gives us a context of what that means, and we can respond accordingly. We may not need to fix anything, because that's just part of the business.
Right.
On the other hand, it's like, our server is under provision. We need to put a little more hardware in there.
Well, and I mean, these are all really important issues because you had that line I love earlier, slow is the new down, right? I mean, you don't see too many, at least public-facing databases crash anymore, thank God, right? So we've kind of solved that problem. But to your point, when it's running very slowly, well, what happens? People get frustrated, they move on, they do something else. Certainly in an e-commerce environment, you've got to be snappy as heck. And I remember talking to one of the industry analysts out there, and they said this was an absolute prime directive at Facebook, was to make sure it's snappy. That's why they built their own database, right? Cassandra. They just went ahead and rolled their own. And you've kind of seen that over the last number of years. And it's really funny. I mentioned Stonebreaker and this, when he said one size fits all. From that point in time, if you look at the explosion of database technologies, it's really remarkable. I mean, you've got MongoDB, you've got Redis, you've already mentioned, you've got MariaDB, which is the old MySQL. That's one of my favorite stories in the business, or what's his Montevidenius, right? So the guy who ran MySQL, it gets bought by Oracle buys Sun, and the next day Monty forked the project to MariaDB. He's like, I'm out.
Yep.
I mean, how funny is that, right? So to the consumer, they're like, oh, what are you talking about? It's this crazy stuff. But the reality on the ground is that it makes a big difference, because now businesses have options. And I've had this theory that a lot of the open source stuff was all targeting Larry Ellison. You know, they're all like, give me a piece of that pie, because Oracle had so much business. I mean, they were just crushing it. But then, you know, they have a bit of a strong arm approach on lawyers rapping you on the knuckles, and nobody likes that stuff. I mean, Microsoft would do that stuff. That's not good for customer experience, right? What do you think about that theory that this open source explosion happened in part because there was a lot of static from the old database world?
Oh yeah, and it's true. You know, I was the president of the big International Professional Association for SQL Server, and at that time, a person I know you've interviewed, Bob Mulia, was the VP for the data platform at Microsoft. And back in those days, say 2005, 2006, their biggest worry was this explosion of open source databases that was a winning favor with the dev community, you know, not just winning minds, but hearts. Right. And so that was one reason why we were able to talk them into giving more support to the user community, because that was our main goal, was to get people enthusiastic about SQL Server. And so, yes, that is the community around open source is a threat to the big commercial platforms. And in fact, you mentioned DB engines a while ago. I believe a big part of the reason that Postgres is seeing and enjoying a very big boom lately is that it's really easy to switch from Oracle to Postgres.
Interesting.
And so a lot of people are like, I like the Oracle database. I personally worked on it for 7 years and loved it, the technology. But when those salespeople roll up in their BMWs and have a fountain pen and a bunch of papers in their hand, people run for cover, because we're gonna have to redo our licenses, you know, and have an audit. So yes, very true. You know, another thing you mentioned in passing, which I'd like to touch on too, is that one of the things that happens in our world as database professionals, as I mentioned, there's a real shortage of expertise. And so one of the things that is maddening to a person who's really serious about databases is that mistakes that were solved decades ago, like when I started in the 80s, we knew about SQL injection. We knew how to fix it. And yet, what is one of the most impactful hack that we see being performed today, not the most common hack,
Right.
not the one that we see used in, by the millions. That would be something like a DDoS attack. But the one that has the most impact is SQL injection still. And to use an analogy, it's like leaving the door unlocked to your house. I mean,
Right.
just lock the door, folks. We know how to deal with this problem.
Right.
And yet it still comes around.
That's interesting. And it's kind of an embarrassment of riches these days in that you have so many options and it's darn near impossible to stay on top of things. Although I will say this juggernaut called Gen AI is getting pretty interesting. And, I've been studying it very closely over the last, I don't know, year or so, I guess. And what I find, and I'm curious to hear your thoughts on this, what's very interesting about it is that people have to remember these are really consensus engines. That's what these models are. And so for any topic that has been widely published, they're going to be really good at getting consensus from all the different papers about how a PostgreSQL database should be designed, about a good data model. In fact, one of my good friends, John Ladley, we were joking the other day about how in the professional world, in the data world, like you'll have a bunch of data architects. Let's say for some insurance company, you might have 20 data architects. And his point was in 3-4 years, you're going to have like 4. Yeah. Because you can use these tools, and the tools will give me a data model for a retail company selling 127 different products and this and that. And it'll be like, okay, and it'll show you. And that's a good starting point. So, and it also can help you analyze code. There's all this talk of no COBOL developers around anymore. What's like, these Gen AI engines, they can do really interesting things, and they can get you like 80% of the way to understanding things. It really is a new sort of co-pilot for people to use as they're in the database world. What do you think?
It's going to change everything. It really is. And one of the ways I think we should just spend an hour talking about this. But you had mentioned how relational databases, are the workhorse of corporate IT, and yet they are actually only about 20% of data that is retained within an enterprise. Right. Whether you're a government agency or a university or a business. The majority of your data is actually in Word documents, memos, emails, Teams, Slack discussions. And that is something that Gen AI is extraordinarily good at ingesting, especially when you're using something like a RAG approach where you're using retrieval augmented Gen AI. And so you can do things like, what is our internal, you can write basically a prompt, a query that says, what is our internal take on this particular technology challenge? And you can see what everyone in the organization has had to say about that. Wow. And, it's just amazing capable. And it's quite funny too, because sometimes what this does at the end of the day, at least for those early adopters, I have a friend who works for an important but not well-known legal company. And they came to realize they didn't have very good data governance in place, because when they asked Copilot, they'd let it go out and crawl through their SharePoint sites and their OneDrives and all that. And so people on the team were like getting information back from the CFO's office and from the internal auditing team, and really very sensitive data that shouldn't be allowed. And that was all because the people didn't tag things. Our systems, unless we have designed them otherwise, are based on the idea of trust. And that's why we get hacked so much. So if you're like, okay, my OneDrive and my team's OneDrive accounts are all owned by them, nobody else can see them, you're just living on a prayer right there, And so once you crawl it, if you haven't designated it already as something that only the CFO team can see, then the people will see it.